Hello friends, in this video I am trying to show that how to run the discriminant analysis in SPSS software. Just a couple of videos back I have tried to explain the concept of discriminant analysis and the assumptions and how can we able to test the assumptions, the validity of the assumptions. Just a recap. The discriminant analysis, the dependent variable is categorical. It may be two, binary nature, or more than two, and the independent variables are ratio scale. The maximum you can use the interval scale values also. If there is the units are same, then it is not essential to go for standardized value. But if the units of the independent variables are different, then it is essential to convert to standardize the value of the variable. And regarding the assumptions, the dependent variable is the assumptions which are mutually exclusive. The predictor or independent variables are ratio scale or interval scale, just now I told, and they are independent, normally distributed, linear, no multicollinearity among the independent or predictor variables, no outlier. Okay, and the sample size, regarding sample size, the sample size should be 5 times more than the number of predictor variables or independent variables. In this case, the number of independent variables are 4, therefore the number of sample size should be at least 5 into 4, that is 20. Okay, the gradation or grade A that obtained in the 10 standard is given as 1 means grade A, which implies more than 80% marks. 2 means grade B, more than 60 to 80% marks, and 3 means grade C, between 40 to 60% marks. And we can analyze the descriptive discriminant analysis into two ways: descriptive discriminant analysis, predictive discriminant analysis. So discriminant analysis is similar to logistic regression, but logistic regression does not require the normality of the independent variables, but discriminant analysis requires. It is also called in the literature that it is the reverse of the MANOVA approach. Okay, so these are the basic things, and through descriptive discriminant analysis, it can tries to explain or tries to distinguish or discriminate the individual or the respondents with respect to their gradation. In this case, the discriminant analysis tries to explain the gradation of the students, okay, on the basis of the independent variables: marks obtained in class 9 final exam, the test marks in class 10, the marks for the project work, internal assessment marks, okay, on the basis of this. And they develop one by taking the linear combination of this independent variable. This analysis develop one function that is known as discriminant function. If the number of gradation, the dependent variable is 2, there is one discriminant function, and it is 3, that is 2 discriminant function. Okay, so in this way, with the help of this discriminant function, the researcher can able to predict the discriminant analysis. In this example, we have used that from the past experience, the school has obtained this data. Now, due to COVID situation, the school or the board cannot able to provide the marks since exam they couldn't able to conduct the exam. So how they can able to provide the marks? Okay, this may be one of the important tools. Okay, so to understand this concept, I have used this one. Okay, now we have exported this into our software. We have already explained the linearity, we have explained the normality. Now we are going to prove the linearity. Okay, for linearity, what you have to do: go to data, go to split files, and you have to organize the output by group. Okay, and group variable is here, group variable, click OK, then go to graph, go to legacy dialog, go to scatter plot, okay, go to matrix scatter, and then define. Up to this extent we have done in the last video. Okay, matrix variables, and then click OK. Okay, up to this extent we have done in last video. Okay, so the result is like this. This is the grade with missing grade. So since we don't have any missing grade, we should ignore the first one, but this is grade A, and the scatter plots are like this with respect to different independent variables. Okay, what we have to see whether the pattern of the scatter plot is just like linear from left to right. Okay, left to right or not, since most of the movement is just like left to right, so this implies that the independent variables are linear. Okay, now for for checking the multicollinearity, what we have to do, go to analyze, go to correlate, go to bivariate, then go to dependent variable list. Okay, dependent variable list. Now this is Pearson's correlation coefficient, two tail. Okay, click OK. It will provide the result. Remember, it should be less than 0.8, because more than 0.8 means highly correlated. There may be the problem of multicollinearity. Since this is hypothetical data, okay, that is why we have got this one. This should not be desirable anyway, since this is hypothetical data. But when the researchers do with respect to field study, it is expected that this correlation coefficient should be less than 0.8 or something like this. Okay, so on the basis of this, we can able to prove that the data does not have the the multicollinearity problem is not there. Now, for testing the the discriminant analysis, what we have to do, we have to go to analyze, go to classify, and then go to discriminant. Okay, go to discriminant. Then the grouping variable, that means dependent variable. Identify the dependent variable, identify the independent variable, just by shift key, independent variable. Now go to statistics. Okay, go to mean, univariate. This is box SM. Okay, within group. Okay, and the grade, define the grade, range of grade. Since we have 1, 2, 3 grades, so you have to give maximum, minimum. Okay, so minimum 1, 2, 3. Continue. Then classify, compute from group sizes, since we don't have equal group. Okay, summary statistic table, leave one out, classification. Okay, continue, and in save, predicted group membership, discriminant score, and the probabilities of group membership. Continue, and then click OK. It is ready. Now it is click OK. The result will come. Okay, and we know the case processing summary. That means the number of missing or out of range group cases are there. No. Okay, so 10 cases are there, the missing or out of range, because we don't have we don't know the gradation, because due to since the board couldn't able to take the exam conduct, so we don't know the gradation. We have to give on the basis of this discriminant function. Okay, so that is why the result is showing like this. Okay, result is showing like this. Now the case processing summary. Okay, now the group statistics with respect to one thing we have to do this, since we have splitted the data, we have to re-split, we have to organize, analyze all cases, do not group cases. Okay, click OK. Now you can go to your analysis, that is classify, then discriminant, then the rest of the things are same. Okay, the rest of the same. Now case processing summary. So valid cases are 32, okay, and excluded are 10. Just now I have explained 10 cases we don't know the gradation. Now regarding group statistics with respect to grade A, grade B, grade C, and with respect to different independent variables. Okay, what is the mean value, what is the standard deviation value, standard value of the standard deviation. So all these are given, so researcher can able to explain just on the basis of this table. Okay, whether in grade C the mean marks for the last exam is higher or not, whether grade A the test marks, so what is the test marks, what is the deviations of marks. In this way the researcher can able to explain this. Now equality, test of equality of group means. Okay, this implies all the 3 out of 4 variables are significant. This implies the the independent variables are clearly explain the predictor variable, clearly discriminate, okay, the dependent variable or categorical variable, but only this variable is not significant. Okay, with lambda for the first one, second one, and the internal assessment case significant, but only in case of project work it is not significant. Okay, and that means its importance for discriminating the grade, discriminating the students with respect to their grade is not so much significant. Okay. Now pooled within group matrices, the correlation within group matrices, it is explained in this way, in this table. The important table is boxes test of equality. Remember, this test should be it should not be significant. Okay, it should not be significant. If it is significant, there is some problem, because it means the null hypothesis of equal population covariance. In the population, the covariance matrices are equal. Okay, we have to accept this one. This is the one of the important outcome.